Hi everyone. Today I want to tell you about a bit of an unusual assessment activity that I've tried twice to considerable success, though I thought we did better the second time than the first time for my purposes, and I want to tell you about why. So first of all, acknowledgements to the students who helped us analyse this data and to the other academics that helped inspire this study. So it sort of started from, I find writing exam questions really hard, but I think I learn a lot by doing it. Maybe the students can too. So I simply set a learning activity. This was in an extra credit course, 50 to 100 first year potential chemistry majors. My goal was to really encourage creativity, encourage curiosity, and a deeper understanding of the content that might have been present in their other learning activities. And it was just write a mastery level exam style question and answer with writing rubric. I did it once, they got some feedback, they did it again, and then I asked them about their experience. And in the context of our first year curriculum, mastery question means something quite precise. It requires a deeper level of understanding that includes one or more of these hexagons. So maybe it's very heavily real world relevant, maybe it's got a problem solving aspect, combining different aspects of the course, and so on.
We approached this project as a piece of action research. We had devised classroom intervention and we wanted to see the effect that it had on students in terms of their creativity, in terms of their sophistication in the way that they could write practice questions. We saw ourselves as a guide or a mentor, and we were very open with the students about this project and why we were doing it, and what we were going to collect and how we were going to analyse the data. So the students really were active participants in the study and they were fully versed in the approach that we were taking. We'd given them the taxonomies we were going to use to classify the questions. We had told them the questions that we were going to ask them about their perceptions of the experience. So the students applied their own knowledge to constructing and writing these questions and answers and explanations of their questions and answers. And then they also answered some questions about how they found the process, so their perceptions such as challenges, benefits, rewarding parts of the experience. We took a grounded analysis approach of the project. So we collected task artifacts, which were the written questions and answers, and also the students' reflections. And we looked at what the data gave us in terms of the themes around student knowledge application in writing these questions, and then perception and experience of the task. We collected question and answer artifacts from 29 students over the 2 years, 2021 and 2022, and we collected student reflections from 28 students over the 2 years. We used Bloom's and Solo taxonomy to categorise the students' questions, and we use these taxonomies as a way of estimating the sophistication of the questions the students were writing. For their perceptions of the experience, we used thematic analysis to draw out themes from those reflections, and we also used thematic analysis around what types of questions the students were writing as well, and if we could get any idea about misconceptions from the questions they'd written as well. We worked in a team of 5 researchers, and so we took an iterative analytical approach, and we tried to reach consensus on each cycle between the 5 of us. I'm sure we're all familiar with Bloom's taxonomy, the idea that we have cognitive processes that a question will ask a student to use when answering. And if we use these verbs in the triangle here, we should elicit down here a less sort of a lower cognitive level response. And up here, it would require more cognitive processing, so slightly harder. So we're looking at the Bloom's taxonomy as being a scale of sophistication. Remember being lower sophistication, and evaluate, create being higher sophistication. And we did ask the students to use these verbs in the questions they were writing or synonyms thereof. The other taxonomy we used to categorise the sophistication of students' questions was the Solo taxonomy, which doesn't look at the verbs used in writing the question and what response that should elicit, but more a student's ability to apply appropriate concepts, connect concepts together, relate them to new ideas. The idea that sophistication moves from pre-structural to extended, abstract being most sophisticated. And we were really looking for the types of questions students were writing and how in writing the question they were able to bring in several different ideas from the course, maybe relating it to a whole new idea would be an example of quite a sophisticated question. Having a closer look at our methodology around this characterization of the students' questions, we took a rule-based approach. So we have these taxonomies, they are a hierarchy. And so the rules are already there about what is sort of a lower cognitive order process and what is higher. But we had to adapt this to suit the learning task that we had actually set up. So we were guided by the content knowledge of the instructor as to what a model answer would be for each level of the taxonomy based on the level of knowledge the student should have and the kind of work we thought they would be able to produce. We marked the questions or ranked the questions based on the intent of the student, so what verbs they had used, for instance, in Bloom's taxonomy. So if they had said explain, then we marked it as a question that was sitting in the explain level. But then we also took on a researcher's interpretation. So if the student had said explain, did explain fit in with what the rest of the question was asking, or were the students really just asking for a recall and had used explain, but not understanding what that term meant? So we took that into account in our analysis. As I said before, we went through our iterative analytical cycles until we reached consensus across the 5 of us. For the experience questionnaire, or the perception of how the students felt this task went, we used inductive thematic analysis, where we didn't assume or look for certain themes in the data. We just wanted to see what the data gave us and were guided by what the data said as to what themes were most prevalent in our students.
So looking at our first year data and considering what did students find most rewarding, our goal was really metacognition. So the task showed me that I actually have the capability to make scientific and experimental links between things in nature, shows me how other minds think and how I can adapt that mentality to assess things from multiple different angles. This is what I was looking for when I designed this activity. But what actually came out even more strongly was this exam strategy and study technique. So students understanding, what did we want when we set exams? I think the rubric was a big part of this, thinking about syllabus points, exam study. When I first saw this, I was like, well, I don't want to create robots that build their skills in answering and applying knowledge to exam questions. I want more curiosity-driven creativity. The idea of the workshops to really to go beyond the exam. But in hindsight, for other contexts, if I was trying to build a whole bunch of school students from differing backgrounds, so maybe I've got low socioeconomic, regional, rural, private schools, public schools, I want to bring them all up to a joint level of understanding of how do you answer an exam question to demonstrate your knowledge and get the marks that you deserve, then that original activity I did in 2021 would be excellent and I would highly recommend it. But for my purposes, I wanted to focus on the increase our interest and curiosity. And that meant really highlighting the creativity and problem solving and reducing that exam focus by eliminating the rubric and taking the word exam style out of the assessment. I also really wanted them to get to higher level of Bloom's taxonomy. So I told them about Bloom's, I told them about solo, which I'll get to in a moment, which was really trying to encourage them to get more sophisticated questions, which was my goal for this particular assessment. And so here in 2022, we did do it fully online. The COVID situation in Australia was quite severe at the time. And we used these different techniques that I'll go through in a moment. Again, we wrote the question, gave feedback, repeated, and then got the experience questionnaire. So in 2021, our data was dominated by understand questions with very little at the higher levels, particularly evaluate. Whereas in 2022, we got much more of this evaluate, analyze, and much reduced number of understands. So we achieved our goal, more sophisticated questions. Solo taxonomy you mightn't have come across before, but basically it starts from unistructural where it's just one single idea. Multistructural, you've got multiple ideas, but they're not really connected at all. It's just two statements of fact. Relational, they start to get collected. And in extended, we actually go beyond that and say, well, this is all the relationship between them, and that means X about something else. And in the beginning in 2021, we had very little understanding and connection between concepts, whereas in 2022, we definitely got much more of this extended relational approach. That was our goal. But this was obviously still an area of challenge for students, linking those ideas And our experience data, our qualitative data actually supports that students found this linking of ideas to be a very challenging thing, but something they could do with scaffolded support to some extent. And so in summary, there was a definite improvement in the sophistication of questions, significant improvement. Look, our data was actually very low numbers because we had trouble getting ethics during COVID. Hopefully in 2021, we can solidify our finding with a bit more quantitative data. It arose that students are very confused by terminology. So they will just use keywords randomly. They'll go evaluate on a question that's clearly just explain, and then they'll use explain for a question that's justified. It actually confirmed the importance of something Siobhan, my co-worker, is working on in terms of developing a joint understanding of the exam questions. And going back to that first bit if we want all our students to be on equal footing and our exams to actually assess all students properly, we need to get our terminology correct. And this link between the different concepts, students definitely recognise the importance, but they really struggled with it. And I think this is an area where they can improve. And if we think about the student perceptions in 2021, again, there wasn't many students, but this exam strategy has just decreased substantially. And I was really pleased to see the interest has gone up, the knowledge gain has gone up. So actually developing more understanding of the particular content, that's another really important thing. And they valued research. So they valued the experience of actually going forward and investigating, well, this concept of intermolecular forces, how is that useful in the real world? They really valued that. So if we go beyond our just most rewarding and think about the most challenging and beneficial, the exam strategy, again, was much stronger in 2021 than 2022. And here we've got the links between the link between the topics is coming through as a big theme. And the fact that the content was challenging, rather than just the decision of which topic should I pick, that's not that important. Question construction did come up both years as something that was hard for them. And there's a question of whether this skill is something we really care about. So the first year I included this in my workshops, it was sort of an add-on bit that I thought might be fun. And it was so much fun that I made it a theme to consolidate 7 weeks of extra credit workshops. I introduced the question formulation technique, which basically enables students to be more purposeful in how they develop sophisticated questions. I would caution that students are scared of asking questions, and we want them to ask a question and then get better at asking questions, not get so scared of trying to ask a perfect question that they never ask anything. And so I actually put it in assessment again and again and again in different contexts, and actually themed the computational chemistry that I was telling them about as a way to ask and answer questions about their content in lectures. So I would argue that we spend a lot of time in the undergraduate degree teaching students how to solve problems that are reasonably well structured to begin with. We give them a whole bunch of variables, they find a formula that's relevant, maybe they think about the consequences of that issue, they solve the problem. But in an authentic workplace situation, I would actually argue that most problems don't come to you with a lot of structure. They're more open-ended, unstructured, and it's actually part of the skill that students need to develop to actually set the problem. So define the parameters and constraints, define the objectives. Where there's no wrong or right answer, they just need to make a decision and evaluate it scientifically. And they need to think about possible solutions, figure out what one they want to think about, which one they want to use. And then they need to ask the right questions. And that's hard. And I would argue this is the skill of a researcher. And scientists need to learn this skill regardless of whether they're going to be academic researchers or they're going to be scientists in workplaces in many, many different contexts. And if we want them to learn this skill, that means we need a learning activity that helps encourage that skill. And this is an example of one that I've tried. Preliminary, lots of refinement needed, but I asked them to select a topic of interest to you based on a whole bunch of stimulus talks that I gave them, mini 2-minute theses. And then I said, specify a molecule and property that you can investigate using computational chemistry that was relevant to that topic. So I'm giving them a little bit of scaffold, but really they have to define their parameters and their objectives, propose a research question, that's just asking the question. And then the so what is what I call it. Why is the research of interest to the topic context? So they actually need to link it explicitly which we found previously was something students found difficult, that linking between different aspects. And so I think this is where I'm looking to go in the future in this particular research area. So the next step for this project is most importantly to get more data so we can get statistical significance to our study. And in order to achieve that, we're going to have to be quite pragmatic in the data collection. And there's a few tips that I've got over a bit of experience in doing this now. First of all, that assessment artifacts is the easiest data to collect. So you're not asking for an additional survey, you're not asking for an additional interview, you're just asking students to do something they already are doing. And then you ask for permission, and the first question, do you consent for me to use this for research? They go yes or no. Ideally, hide this information when you're marking the rest of the assessment, otherwise not ethically good. But that's pretty easy to do nowadays. And then I would encourage you to include the metacognitive questions as part of the assessment. So I actually mark students on, tell me the most rewarding part of this activity, tell me the most challenging part of this activity, because I think it's a really important skill for them to have. And the side benefit is we get great research data. That's not the primary reason we put it in. We also wanted to think about students' perception of confidence and learning in chemistry, and think about whether this writing questions as assessment, whether this curiosity and creativity is actually helping them there. We've got some hints from the quotes. We just want to quantify that a bit more precisely, and we're going to use some different techniques to do that in the future. Thank you very much.